Evaluate the limit as x approaches infinity of x over x plus 9. Now first off, intuitively, if we plug in a very large number, we would have that large number divided by that large number plus 9. But 9, in comparison to the extremely large number, is basically 0. It's minuscule in comparison to that number. So we can just treat it as if it doesn't exist and say it's that large number over that same large number, which would be 1. And so we would say this limit is equal to 1. And it is, actually. And there's a couple different algebraic techniques we can use. One is synthetic division. If you remember that, we put the x coefficient here, and then the constant coefficient is 0. We're dividing by x plus 9, so we put the negative 9 here. We do our synthetic division. I'm not really going to go into too much detail. And our answer would be 1 minus, and our remainder would be 9. Our remainder is negative 9, so it's minus 9 over our divisor x plus 9. And so this is what we get. This expression is equivalent to this expression. And so if we take the limit as x approaches infinity, this denominator would be huge, right? It'd be a large number plus 9. And so this whole term, 9 over a large number is basically 0. And so this whole term would go to 0, and we end up with 1. Or another way we can think about it is if we divide the numerator and denominator by x, because it's the highest power in the denominator, we'll get x times 1 over x, that's just 1. And then in the denominator, the 1 over x applies to both terms, so it would be just 1 plus 9 divided by x. And so if we take the limit of this as x approaches infinity, you'll see everything will stay the same except for this x here. If x is really large, 9 over that really large number would go to 0. So this term would be 0. We would get 1 over 1, which is 1. So 3 different ways we can figure it out, and we'll get the answer 1. Now there's a shortcut. If you see a rational function where the degree of the numerator is equal to the degree of the denominator, this is the shortcut method to calculate these limits, then it's just the leading coefficient, the ratio of the leading coefficient. So in other words, it's just 1 divided by 1 in this case, and so that's why the answer is 1.